Hi everyone, this video is going to be about surds and how we can simplify surds. And the concept of a surd will probably be new to absolutely everyone watching this video, as it's a concept that's generally learned in year 10 maths at higher levels. So a perfect square is a number that is a square of another whole number. So say, for example, 1 squared equals 1. So 1 is a perfect square. 2 squared is 4. So 4 is a perfect number. Perfect square rather. 3 squared is 9, so that's a perfect square. 4 squared is 16, so that's a perfect square. 5 squared is 25, 6 squared is 36, and so on. So further perfect squares are 49, 64, 81, 100, 121, and so on. And so because they're perfect squares are the result of squaring a whole number, we can therefore find the square root of a perfect square very easily. So we see here if 3 squared equals 9, that means the square root of 9 equals 3. They're just inverse operations going back to what we were talking about with equations. They're opposites. But now we need to think, so what about this if we're trying to find the square root of a number that isn't a perfect square? Say, for example, you see here I have the square root of 20. When you chuck that into your calculator, you get 4.472135,955, so on and so on and so on. That's going to be an infinitely long number, and it has no pattern behind those numbers as well. So we call that irrational. It's an irrational number. But specifically, that irrational number comes from square rooting a number that's not a perfect square, and we call them surds. So a surd is when we have a square root of a number that isn't a perfect number. The word surd is short for absurd. And we can simplify this by splitting them into their factors. So looking at the bottom here, if we're trying to find the square root of 20, the square root of 20, 20 can be written as the product of 4 and 5. So the square root of 20 is equal to the square root of 4 times the square root of 5. That's useful because we know what the square root of 4 is. The square root of 4 is 2. So really, the square root of 20 can be written as 2 times root 5 because the 2 comes from the root 4. And that's what simplifying surds is. It's splitting it into their perfect square factors and then reducing it from there. So on this page, we just got 4 examples that we'll go through. But before we go through the examples, it's useful to have all the perfect square numbers in front of you because that's what you're going to be using to split them. So let's just write them down. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared 36, 7 squared 49, 8 squared 64, 9 squared 81, 10 squared 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, and so on. We'll just leave it there. We're not really going to go any further than that. So we have each of these numbers, and we're going to use these as kind of tools. We want to look at these surds and think about, well, how can I split it into one of these numbers? So looking at the square root of 18, we want to think of, well, what are 2 numbers that I can multiply to be 18, where one of them is one of those perfect squares? Looking at this list at the top, you'll see that 9 is one of those. So we can square root 18 to be the square root of 9 times the square root of 2, because 9 times 2 equals 18. Now we have no idea what the square root of 2 is. We can put it into our calculator. It's going to give us like 1.414 something or other, but we do know what the square root of 9 is. We know that's 3, so we can write this as 3 root 2. And there we go. We've simplified that surd. We can't do anything more to that. It is still a surd, but at least we've written the surd in its simplest form. Let's look at this next one. We want to find the square root of 48. We want to simplify that. Again, if you try putting the square root of 48 into your calculator, like if I just do it now, square root of 48 equals 6.92820323 and so on. So we don't know what this actually is, but we can split it up. So what we can do is maybe we can split it into 4. We see that 4 is a factor and is a perfect square. So we can rewrite this as square root of 4 times the square root of 12. Now, the square root of 4 times the square root of 12. Again, we don't know what the square root of 12 is, but we do know what the square root of 4 is, and that's 2. So we have 2 root 12. And you could say we have technically simplified this surd. However, we can simplify this a bit further as well, because 12, we can also split that up a little bit more. Well, we can split 12 into 3 times 4, 4 being one of those perfect squares. So this would be 2 times the square root of 4 times the square root of 3. The square root of 4 is 2, so this is saying 2 times the square root of 3, which equals 4 root 3. And that is actually the fully simplified version of square root of 48. Now, alternatively, you see that I split it into 4 and 12 and then 4 and 3 later on. What you could have also done is skipped right to it as well, because instead I could have done 48 could also be written as the square root of 16 times the square root of 3, and the square root of 16 is 4. So we'd skip right to 4 root 3. Either way, you see that I got the same answer, but if you just think about it a little bit longer, you might be able to see that there's a quicker step rather than having to simplify the surd twice. So let's look at the square root of 108 for this third example. So looking at the square root of 108, we could split this into 4 and 27. Yep. If I do 27 times 4, I could split this into root 4 times root 27. Oop, not 24. 27. And then I could start splitting from there and then split 27 again. Or again, if you can try to find a larger square, a perfect square that goes into 108, that will make it a lot quicker. 108 is actually 36 times 3. So we can split this into 36, square root of 36 times the square root of 3. The square root of 36 is 6. So this is just 6 root 3. So we skipped right to the end because we can't split square root of 3 anymore. Lastly, the square root of 175. Just looking at each of these options again, there's only one number really that we can split this into, and that's going to be 25. So 175 is the same as saying the square root of 125 times the square root of 7, because 7 times 25 is 175. The square root of 25 is 5, so we just get 5 root 7. You can always check to see if your answers are right, by the way, by just simply putting it into your calculator and see if you get the same thing. So if I do the square root of 175, that will give me about 13.2287. And if I then did 5 times the square root of 7, that also gives me the same number, 13.22875. You should end up with the same answer at the end. Anyway, so this is how we simplify surds. Like I said, it's a new concept, but once you get familiar with those perfect squares and splitting them into their different surds and reducing them further, you'll see that it's actually not too bad. Have fun.